everybody, we're talking about using midpoint and distance formulas today. Going back a little bit to something that's a little bit more like algebra than it is geometry. You can write, if you're taking notes, you can write down the header. Otherwise, I'm going to move to the next page and then just jump right into it. So these are both formulas. So because they're both formulas, they're easy just to plug in numbers to, right? We kind of like these. So let's say we're going to use the midpoint formula to find where the middle or the midpoint of a particular segment is. So here the endpoints of segment RS are at R, which is over at 1, -3. And the second point is at S, over at 4, 2. And I'm just going to draw them to give us a nice visual. Again, 9 times out of 10, a visual will help you in geometry. To use the midpoint formula, we have it here. We have x1 plus s2 over 2, comma, because it's going to be an ordered pair. It's a coordinate. Y1 plus y2 over 2. Kind of like with the slope formula, it's nice if you label your points x1, y1, and x2, y2. Then I'm going to plug them into my midpoint formula. So my x1 and x2 are 1 and 4. My y1 and y2 are -3 and +2. And then doing order of operations, we'll do the stuff grouped together. So the numerator stuff together, and then we'll end up dividing. So if I add 1 and 4, I get 5. If I add -3 and 2, I end up with -1. Neither of these are actually going to be whole numbers. So when you're graphing, it's usually easier to write them as a decimal. So this will be 2.5 and -0.5. There's your midpoint. Now to give you the visual, on my picture, if I go over 2 and a half, and then down -1/2, it looks to be about the midpoint of that segment, right? So this is an algebraic way of writing out numerically how to find the midpoint, and it corresponds to the exact midpoint in your picture. All right, so let's move on to another one. Let's do one where we have to find an endpoint. So like number 4 here. We're still using the same formula. There's just several ways to do it. There's the easier way, and there's the harder way, and there's the visual way. I'm going to show you each one. I'm going to say what's probably going to be your most favorite for last. So the first way is that we're told the midpoint is this dude here. One of the endpoints is 4, 4. Find the other endpoint. 9 times out of 10, students will make the mistake that they'll plug these 2 points in your midpoint formula. The midpoint formula, you got to make sure you plug stuff in the right place. y1 plus y2 over 2. For the midpoint, we know the midpoint is -1, -2. Goes over here with the m, not over here. For our 2 endpoints, you know one of them has 4s for x and y. And the question is, okay, well, how do you find out what this x is and what this y is? Well, if I color coordinate these, x is -1, so this whole thing should equal -1. Y is -2, so this whole thing should equal -2 because it's the y coordinate. And then I'm not going to finish it out because it's so long and you really don't need to do it. You just put this over 1 and you cross multiply like a proportion. It just takes forever, right? There's got to be a more efficient way to do this. And there is. So I'm not even going to finish that way because you're not going to like it. So here's the way that you're really going to like, all right? Okay, M is the midpoint. I'm going to put it in the middle. One of my endpoints in VW is W, 4, 4. I'm going to put that one over here. My other endpoint, the V, is going to be somewhere over here. Y'all with me there? All right, so put the midpoint in the middle, put my second endpoint on the right, put my first endpoint, V on the left. I just don't know what it is yet, okay? So how do you go from -2 to 4? Well, to go up to 4, you added 6, right? You went -2 to get to 4, you add 6. So to find my other endpoint going in the opposite direction, I'm going to subtract 6. So if I do -2 minus 6, it's -8. All right, so again, to go from the middle to the end, I added 6. To go from the middle to the other end, I'm going to subtract 6. For the -1, to go to +4, I'm adding 5, right? So to go from the middle to one end, I added 5. To go from the middle to the other end, I'm going to subtract 5. So -1 minus 5 is -6. So my answer, the endpoint, is -6, -8. Again, I just write everything out. I put the midpoint in the middle, one endpoint on one side, one endpoint on the other side. To go from the middle to the end, I added some things. To go to the other end, I'll subtract it. All right? That's the quick and easy way to do the endpoint formula. The last one is the distance formula. The distance is synonymous with finding length when you're in the coordinate plane. So if I want to find the length of this segment, or the distance in between those 2 points, I'm going to label my points x1, y1, x2, and y2, just like I do with the midpoint formula and last year with the slope formula. Then you're just going to plug in those numbers into this formula here. It's under a long square root symbol. I subtract my x coordinates and square it. I subtract my y coordinates and square it, and then I add that stuff together. All right? We'll do one example like this. So if you need to write this down, pause it. Otherwise, keep moving with me here. All right, so the length of segment RS. All right, so we're going to use the distance formula. So the square root of that long thing, x2 minus x1 squared plus y2 minus y1 squared. I'm going to label my points. I know that R is 2, 3. I know S is 4, -1. And, excuse me, I'm going to label one x1, y1, x2, and y2. You technically could have just done that up here and not had to put it in the graph. Totally your call if you want to do the visual stuff down here or not. So now that I've labeled everything, I'm just going to plug it into my distance formula. So I'm finding the length of RS. So my x coordinates, x2 and x1, are 4 and 2. So 4 minus 2. And then here I'm going to do y2 minus y1, -1 minus 3. And then from here it's just order of operations. We start with whatever's inside parentheses. So 4 minus 2 is 2. -1 minus 3 is -4. Now there are 2 big mistakes students usually make. One is not leaving this stuff in parentheses. Okay? Here's why. If you didn't leave this in parentheses and you just typed it in your calculator, well, 2 squared is still going to give you 4. If you type this in your calculator without the parentheses, it's going to give you -16, when really it's supposed to be +16. Remember, when you square something, it's something times itself. Well, if you do -4 times -4, a negative times a negative is +16. Your calculator, if you don't put your parentheses, it's going to think you're doing -4 times 4, so -16, which is wrong. So make sure when you're typing this in your calculator, if you use a calculator, that you put this inside the parentheses. The second big mistake students make is they like to take the square root from this point. You cannot do that. Order of operations, you add next. You don't do your square root symbol until the very end of this, all right? And then the square root of 20, you actually get a decimal or an irrational number when you get the square root of 20. I'll say you can round it to the nearest tenth. So this would be about 4.5. In the future, I will not allow you to do that once we cover simplifying radicals, which you won't do until the spring. So for now, 4.5 is enough. So to retract our steps, you label your points, x1, y1, x2, and y2, plug them in your distance formula, then it's order of operations from there. And that says that this segment here is about 4.5 units on the coordinate plane. So that's it, midpoint and distance formula. Hopefully this was helpful for you.